Bonjour. Welcome to Washington's Education Center's Radio Zoom classes. This is SVN3E, Grade 11 Workplace Science, and I'm the teacher, Bronwyn Slade. Our classes are scheduled from Monday through Thursday from 10 to 11 in the morning, and we are wrapping up our third week of our 9-week course. At this point, you should be thinking about what work to submit for marking. So a reminder that the key questions are listed at the end of your IL lessons in your booklet. So please do all of them. Do the check your understanding questions, the activities, the review questions. You can explain your ideas and your thoughts in complete sentences, please. So make sure you're actually answering the question and giving me a complete full answer. You can do this by hand or electronically. If you want to write in your workbook, feel free, that is fine. But the spaces are pretty small, so I would encourage you to do it on a separate piece of paper to just give you yourself the opportunity to give me your full ideas. If you want to do it electronically, Word and Google Doc files are the easiest for me to open. Also, a PDF is totally fine. So try to hand it in those forms. If you need to use a different type of form, that is most likely fine. Just touch base with me so that I can make sure that I can open your forms. Everyone has access to Google Doc files through your NNEC email address. If you're not trying to do that, let me know and I can walk you through. All right, so how do you actually submit your work? So the first method is to send your work electronically. This is probably the fastest way. If you scan your completed work in, if you've done it by hand, you can use a device. You don't have to have a scanner. So if you have an Apple device using the Notes app or the Android device, the Google Drive app, both have scan functions that are fairly straightforward. You can just point and click pretty much. This makes the file pretty small and if you have multiple pages all on in one file. So it makes my life a little bit easier. If that doesn't work for you, if this is too complicated for you, that's totally fine. Then you can send me pictures. That works. I can make that work. Then send it to me either through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can send it to me through Facebook Messenger to B Slate Wahsa. The second way to submit your work is to drop it off in Sioux Lookout. We have an outdoor mailbox at our location 74 Front Street. We're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. We are not yet open to the public, unfortunately, hopefully soon. But for now, just put your work in that mailbox and I'll get it back to you as soon as I can. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students are also welcome to hand in their work through fax. If you have access to a fax machine, that is completely fine. All right, if you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B Slate Wahsa. So you can friend me on Facebook or subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our lessons. All of our Radio Zoom classes are recorded and I upload them shortly after airing to YouTube, and I put them under a playlist called SVN3E. This way, all of our lessons are easy to find and you get the full experience. There's also a list of supplementary videos where all of the videos that are available on YouTube that we watch in class are listed there as well. So you can find them from the original sources and then follow them if you are interested in those topics. Science is a really visual subject. I try to incorporate as many videos, images, graphs, charts, things like that as I can. So really accessing the videos is going to set you up for the most success to truly understand all of this content. If you can't join me live through Zoom, then accessing the YouTube videos is totally fine. You don't need to be here live. If you can't access the YouTube videos because you don't have reliable internet or something like that, let me know and I can send you a copy of the recordings so that you can still get the full experience. All right, if you have any questions or concerns, please reach out and contact me. My email address is bronwyn.slate@nnec.on.ca, and that's spelled BRONWYN.SLATE. My Facebook is B Slate Wahsa. You can call me at the office at 807-737-1488, extension 2209, or also toll free at 1-800-667-3703. My office hours this term are 8 till 2. But if that doesn't work for you to connect, then let me know. Leave me a message, send me an email saying that you'd like to talk and that doesn't work, and we can try to find something that works for both of us. I think it's really important to position myself within the context of this course, as that impacts how I teach the course. I, your teacher, have white settler ancestry. I have white privilege, and this means that my experience of education has been easier than many other folks. The education system is set up for my success as a white person. I recognize this, and though I can't change that directly, I can't take away my white privilege. I will always have white privilege. I work to disrupt those cycles and to do the best that I can do to be an anti-oppressive educator. I do live in the Northwestern Ontario area on the traditional territories of the Anishinaabe people. So I honor and respect this culture and these people, and I'm trying to integrate teachings when I can into this course. It is a long process and not something that comes easily to me. So I am working on it and trying to do my best, though it is something that I will have to keep working on continually. This is because as an educator, I have lots to learn and unlearn, and it's, again, a process. So I will keep working on it. If anyone has any suggestions or comments about how I can do better, please let me know and I will do my best. I've also noticed that our textbook is Eurocentric. So many of the examples and the communities or comments that they make about people are focusing on white culture, on European or Eurocentric scientists and communities, and this is problematic as it erases and ignores Indigenous, Inuit, and Métis knowledges as well as experiences. This does not represent the true reality of our communities as well as our society as a whole. So I, again, work to integrate when I can, when what I know about in terms of Indigenous, Inuit, and Métis knowledges as well as experiences into our coursework. But if people have suggestions about how I can do this better and has resources, I'm welcome this and would really appreciate any support. I've been looking into textbooks and there's not a lot of options, but I will keep trying to find something that is better. All right, so we are looking at Unit 3 starting today. So this is the environmental effects of humans. So in this unit, we'll learn how factors in the environment can cause disease in humans. Then we'll learn about how vaccines and other ways to protect ourselves from these factors. So we've already talked a lot about how humans have impacts on the environment, how our activities, how our choices, what we do, how we live affects ecosystems and the environment. But now in this unit, we're going to be learning about how the environment can then affect us physically. So we're going to be looking at lesson 8 today, which are common environmental factors. Again, this unit touches upon this, so we're going to be looking at it in small chunks in terms of how environmental factors affect our health. So our learning goals are that at the end of today's lesson, you'll be able to identify and describe several pollutants, and you will understand the effects of pollution on humans. So interestingly enough, though we are talking about the environmental effects on humans, it's kind of circular because we're looking at how pollution affects us. So this is a result of our human activities, which has impacted the environment, which now we're going to be talking about how it impacts us. So you know that you've met the learning goals because you can explain the causes of air, light, noise, soil, and water pollution. And you can explain the impacts of pollution on humans, plants, and animals. So it's important to understand this first. A pollutant is a waste material from human activities that can cause harm in an ecosystem. Pollutants are also environmental contaminants, substances that may harm humans or other living things when released into the environment. So pollutants are a result of human activities. All right, so first, air pollutants. There are 5 major air pollutants that we're going to talk about, and they result from human activities. They have both direct impacts on human health and indirect consequences. So the sources of emissions from air pollutants, so where it comes from, are, and this is from 2002, so these numbers may have changed, but this is the most recent information that I was able to find that was pretty accessible. So industry is 52%, transportation 27%, consumer and commercial products 8%, agriculture 10%, commercial and residential heating 1%, and other 2%. So industry and transportation are really the biggest emitters for air pollution. And this is probably, though these numbers may have changed, these are probably still fairly true today. So in Ontario, so information that's a little bit more recent, 2014, we have road vehicles is 34%, other transportation is 37%, and then these are all parts of industry. So we have smelters, primary metals is 3%, cement and concrete is 4%, other nitrous oxide industrial sources is 9%, miscellaneous and residential is 9%, and utilities is 5%. So really transportation is the huge piece, though this transportation might fall under like industrial use of transportation. It's going to have transportation use as well. So, but that is the huge part for Ontario. So let's look at what these 5 common polluters are. So carbon monoxide, which the scientific element is CO, is how we represent carbon monoxide, is a gas that comes from the burning of fossil fuels, mostly in cars. It cannot be seen or smelled. So this, as we just looked at, cars, this is going to be a big one for Ontario because we have so much transportation as an emitter. So where it comes from, carbon monoxide is released when engines burn fossil fuels. Emissions are higher when engines are not tuned properly and when fuel is not completely burned. So this is why maintaining your vehicle is really important. Cars emit a lot of carbon monoxide found outdoors. So most of the carbon monoxide that we find outdoors is from vehicles, though furnaces and heaters in the home can emit high concentrations of carbon monoxide too if they're not properly maintained. So this is furnaces and heaters also contribute to it. So then the effects on humans is that carbon monoxide makes it hard for body parts to get the oxygen they need to run correctly. Exposure to carbon monoxide makes people feel dizzy and tired and gives them headaches. In high concentrations, it can be fatal. Elderly people with heart disease are hospitalized more often when they are exposed to higher amounts of carbon monoxide. So if you have an underlying condition, you're going to potentially have a higher rate of impact of carbon monoxide. And carbon monoxide poisoning is something that happens in fairly commonly. Being dizzy or tired or having headaches all the time can be a result of carbon monoxide. So you should have a carbon monoxide detector in your home because, as it's said, you don't see it or smell it, so you don't know that it's there. So that it will let you know if you have a high rate of carbon monoxide in your home or in your workplace, in buildings that you're in frequently, to make sure that you are breathing clean oxygen, clean air, so that you can get the oxygen that you need. So in 2010, looking specifically at carbon monoxide, 75% of the carbon monoxide emissions came from transportation. So then you could also see residential fuel, so wood combustion or the wood industry, the aluminum industry, the upstream petroleum industry, and then other sources are all under 10% each. But really transportation is where our carbon monoxide emissions come from. All right, so then sulfur dioxide, which is SO2, is another one. So it's a corrosive gas that cannot be seen or smelled at low levels, but can have a rotten egg smell at high levels. So where does it come from? Sulfur dioxide mostly comes from the burning of coal or oil in power plants. It also comes from factories that make chemicals, paper, and fuel. Sulfur dioxide reacts in the atmosphere to form acid rain and particles. So we've talked a little bit about sulfur dioxide before and the effects, but particularly on humans, sulfur dioxide exposure can affect people who have asthma or emphysema by making it even more difficult for them to breathe. It can also irritate people's eyes, noses, and throats. Sulfur dioxide can harm trees and crops, damaging buildings, and make it hard for people to see long distances. So there's various effects, and all of these, the longer that you're exposed to these things, the greater the impact, and the higher levels that you're exposed to things are going to have a bigger impact on you. So in 2010, the Canadian sulfur dioxide emissions came from, the highest amount was from non-ferrous smelting and refining. So that's going to be part of industry, 27.2%. And then the petroleum industry, 24.3%. The electric power is 24.5%. And then other industrial sources, 13.5%. Marine, 6.2%, transportation, 0.7%, and other sources, 3.6%. So really all of these, the non-ferrous smelting, petroleum, industrial, and electric power are all industrial systems. So that's where most of our sulfur dioxide comes from. Then we have nitrogen oxides. So this is NOx because there's various nitrogen oxides. So some of them, so there's going to be different numbers next to the O, depending on if we're talking about sulfur dioxide, or sorry, nitrogen dioxide, nitrogen trioxide. There's various things. So we just say, we group them all together to be nitrogen oxides. And then we have an X here to represent a variable that it could be various numbers. We don't need to look to, like, that doesn't need to be too much of a concern for us. So this is a reddish brown gas that comes from the burning of fossil fuels. It has a strong smell at high levels. So where does it come from? Nitrogen dioxide mostly comes from power plants and cars. Nitrogen dioxide is formed in two ways: when nitrogen in the fuel is burned, or when nitrogen in the air reacts with oxygen at very high temperatures. And nitrogen dioxide can also react in the atmosphere to form ozone, acid rain, and particles. So we've talked about how nitrogen is a big piece of, or a large part of our air is made up of oxygen. So how it reacts, with nitrogen. A large part of our air is made up of nitrogen, and how it reacts depending on the situation with oxygen could create something that has a negative impact on us. So the effects on us is that high levels of nitrogen dioxide exposure can give people coughs and make them feel short of breath. People who are exposed to nitrogen dioxide for a long time have a higher chance of getting respiratory infections. And nitrogen dioxide reacts in the atmosphere to form acid rain, which harms plants and animals, which we've talked about before. So the sources of nitrogen oxides in 2016, where it came from, and this is in tons. So this graph shows it is different layout than the ones that we've looked at before. So the mobile sources, so transportation is a large part. We can see that that's about half of the amount. The oil and gas industry, other industrial sources, electric power are basically the rest of the chunk of our graph. And then the commercial, residential, and institutional is a smaller portion, and then an even smaller portion are from other sources. So then we have particulate matter, which are PM, which we've talked about briefly before. So this is the solid or liquid matter that is suspended in the air. To remain in the air, particles usually must be less than 0.1 millimeters wide and can be as small as 0.00005 millimeters. So remember, this is really, really small, but still, so it's in our air, these little bits of stuff, but they're not elements. They're other things that we can then inhale and have an impact on us. So where do they come from? Particulate matter can be divided into two types: coarse particles and fine particles. Coarse particles are formed from sources like road dust, sea spray, and construction. So these ones we very possibly notice. Fine particles are formed when fuel is burned in automobiles and power plants. So this is like sort of, we can kind of notice this in terms of like smoke or smog coming from, even from a fire. Those are going to have small particles. So the effects are that particulate matter that is small enough can enter the lungs and cause health problems. Some of these problems include more frequent asthma attacks, respiratory problems, and premature death. Particulate matter is also irritating to the skin. So you may have experienced this in terms of like being next to fire and inhaling the smoke, and it makes you cough. You're breathing in these little bits of smoke, these fine particles, and that's having an impact on your health. So again, this from the sources of emissions from 2016. So home firewood burning, like I just talked about, burning wood is going to is a large percentage, over 50% of where the particulate matter in our air comes from home firewood burning. Then from mobile sources, so transportation, the ore and mineral industry and manufacturing, and then oil and gas industry. So the rest is basically from industry with some other sources. And now we're going to look at hydrocarbons and photochemical smog. So this is a large group of chemicals commonly found in both indoor and outdoor air. With some give off distinctive colors at higher levels, they may be present even if you can't smell them. So this is chemicals in our air that we don't necessarily know are there. So the sources, so volatile organic compounds, or VOCs, form a large group of chemicals commonly found in both indoor and outdoor air. So this comes from vehicle exhaust, cigarette smoke, cooking, especially when you're frying, building materials like paint, glues, varnish, air fresheners and cleaning products, candles and incense, petroleum use, trash incinerators, and evaporation of industrial chemicals. So these are all things that these are all contributing to air pollution. Even though like air fresheners, it's an air freshener, it's supposed to make the air smell nicer, but you're still putting a chemical into the air to cover other things, and that's still contributing to air pollution. So the effects of this is that short-term exposure to high levels of some VOCs can cause fatigue, nausea, dizziness, headaches, breathing problems, and irritation of the eyes, nose, and throat. Some people may be more sensitive, such as children, seniors, pregnant people, and people with existing health conditions, such as asthma, chronic pulmonary disease, or bronchitis. Also thinking of allergies, more and more people are realizing that they're allergic to scents, and so having incense or candles or air fresheners or perfumes or colognes, things like that are impacting people more and more. Recently, my toddler was visiting family and didn't want to go into a bathroom because he said that it was smelled too fruity, and the air freshener that was in there, he was having a hard time breathing because of it. It was too much for him. We have sensitivities in our family, so we really don't have scents in our home, and so he really hasn't been exposed to them, and that just made it too hard for him to go into that bathroom. So just these are sorts of things that we don't necessarily think about the impacts that they have on people. Also, long-term exposure to high levels of some VOCs may result in adverse health effects, including cancer, and more research needs to be done to understand the impacts of low-term level exposure. So if it's low level, but for a long, long time, what does that mean? They're still doing research on this. All right, so then what are the emissions? Where does this come from? So this is About a third is the oil and gas industry. And then paints and solvents is significant. Transportation, home firewood burning. These are all sort of similar amounts. And then other industrial sources. So still various industrial sources is where this comes from. All right, so now you can do the key questions on page 65, your check your understanding questions. And what are the 5 major air pollutants that result from human activities? We've just gone into that in a lot of detail. All right, light pollution. So before we can look at light pollution too much, we are going to learn about the electromagnetic spectrum just to understand how light works. So we're going to watch a video just to first spectrum before we look at the pollution, because it's important to understand light first.
Something surrounds you, bombards you, some of which you can't see, touch, or even feel. Every day, everywhere you go, it is odorless and tasteless, yet you use it and depend on it every hour of every day. Without it, the world you know could not exist. What is it? Electromagnetic radiation. These waves spread across a spectrum from very short wavelengths to X-rays, ultraviolet rays, visible light waves, even longer infrared waves, microwaves, to radio waves which can measure longer than a mountain range. This spectrum is the foundation of the information age and of our modern world. Your radio, remote control, text message, television, microwave oven, even a doctor's X-ray, all depend on waves within the electromagnetic spectrum. Electromagnetic waves, or EM waves, are similar to ocean waves in that both are energy waves. They transmit energy. EM waves are produced by the vibration of charged particles and have electrical and magnetic properties. But unlike ocean waves that require water, EM waves travel through the vacuum of space at the constant speed of light. EM waves have crests and troughs like ocean waves. The distance between crests is the wavelength. While some EM wavelengths are very long and are measured in meters, many are tiny and are measured in billionths of a meter, nanometers. The number of these crests that pass a given point within 1 second is described as the frequency of the wave. One wave, or cycle, per second is called a hertz. Long EM waves, such as radio waves, have the lowest frequency and carry less energy. Adding energy increases the frequency of the wave and makes the wavelength shorter. Gamma rays are the shortest, highest energy waves in the spectrum. So, as you sit watching TV, not only are there visible light waves from the TV striking your eyes, but also radio waves transmitting from a nearby station, and microwaves carrying cell phone calls and text messages, and waves from your neighbor's Wi-Fi, and GPS units in the cars driving by. There is a chaos of waves from all across the spectrum passing through your room right now. With all these waves around you, how can you possibly watch your TV show? Similar to tuning a radio to a specific radio station, our eyes are tuned to a specific region of the EM spectrum and can detect energy with wavelengths from 400 to 700 nanometers, the visible light region of the spectrum. Objects appear to have color because EM waves interact with their molecules. Some wavelengths in the visible spectrum are reflected, and other wavelengths are absorbed. This leaf looks green because EM waves interact with the chlorophyll molecules. Waves between 492 and 577 nanometers in length are reflected, and our eye interprets this as the leaf being green. Our eyes see the leaf as green, but cannot tell us anything about how the leaf reflects ultraviolet, microwave, or infrared waves. To learn more about the world around us, scientists and engineers have devised ways to enable us to see beyond that sliver of the EM spectrum called visible light. Data from multiple wavelengths help scientists study all kinds of amazing phenomena on Earth, from seasonal change to specific habitats. Everything around us emits, reflects, and absorbs EM radiation differently based on its composition. A graph showing these interactions across a region of the EM spectrum is called a spectral signature. Characteristic patterns, like fingerprints within the spectra, allow astronomers to identify an object's chemical composition and to determine such physical properties as temperature and density. NASA's Spitzer Space Telescope observed the presence of water and organic molecules in a galaxy 3.2 billion light-years away. Viewing our Sun in multiple wavelengths with the SOHO satellite allows scientists to study and understand sunspots that are associated with solar flares and eruptions harmful to satellites, astronauts, and communications here on Earth. We are constantly learning more about our world and universe by taking advantage of the unique information contained in the different waves across the EM spectrum.
All right, so that just tells us, gives us some understanding about how waves are measured. Now we're going to look specifically at ultraviolet radiation, which is how light pollution happens here on Earth. Let's look at this video.
Swirling spiral arms of galaxy M33 can be seen in visible light, but the true extent of these spiral arms are revealed in ultraviolet light. Just as a dog can hear a whistle just outside the range of human hearing, bugs can see light just outside the range our eyes can see. A bug zapper emits this ultraviolet light to attract insects. Johann Ritter conducted an experiment in 1801 to find out what, if any, electromagnetic waves are beyond violet. Ritter knew that photographic paper would turn black more rapidly in blue light than in red light. So he tried exposing the paper beyond the violet end of the visible spectrum. Sure enough, the paper turned black, proving the existence of light beyond violet, ultraviolet rays. These ultraviolet rays, or UV radiation, vary in wavelength from 400 nanometers to 10 nanometers and can be subdivided into three regions: UVA, UVB, and UVC. Visible light from the Sun passes through the atmosphere and reaches the Earth's surface. UVA, long-wave ultraviolet, is the closest to visible light. Most UVA also reaches the surface, but shorter wavelengths, called UVB, are the harmful rays that cause sunburn. Fortunately, about 95% of these harmful UVB rays are absorbed by ozone in the Earth's atmosphere. UVC rays are the shortest and most harmful and are almost completely absorbed by our atmosphere. The ozone monitoring instrument aboard NASA's Aura satellite detects ultraviolet radiation to help scientists study and monitor the chemistry of our atmosphere, including UV-absorbing ozone. While atmospheric protection from harmful UV radiation is good for humans, it complicates the study of naturally produced UV rays in the universe by scientists here on the Earth's surface. Young hot stars shine most of their light beyond the visible light spectrum at ultraviolet wavelengths. Scientists need telescopes in orbit above the Earth's UV-absorbing atmosphere to find and study these UV-bright regions of star formations in distant galaxies. New young stars in the spiral arms of galaxy M81 can be seen in this Galaxy Evolution Explorer GALEX image from NASA. Chemical substances, both atoms and molecules, interact with UV light, making this region particularly interesting to scientists. An ultraviolet instrument aboard Cassini has detected hydrogen, oxygen, water ice, and methane in the Saturn system. UV data have also revealed details of Saturn's aurorae. Scientists also use UV waves shining from distant stars to view permanently shadowed regions of lunar craters. The Lyman Alpha Mapping Project, or LAMP, instrument aboard NASA's Lunar Reconnaissance Orbiter can use this faint starshine to look for possible water ice on the Moon. Ultraviolet rays may be harmful to humans, but they are essential to studying the health of our planet's protective atmosphere and give us valuable clues to the formation and composition of distant celestial objects.
That gives us a bit more information than we actually need, but it shows us how UV rays can be really harmful. Those really short waves can be harmful to humans. All right, so now we're going to move on to noise pollution. So excessive sound can be harmful as sound exerts pressure on our ears. Any unwanted sound is can be thought of as noise pollution. So the pressure of sound is measured in what are called decibels, and it's indicated with a little d and a capital B as a unit of measurement. Hearing loss begins when a person is exposed for 8 hours or more to sound above 85 decibels. So here is the decibel scale. So 0 is no sound, silence. 10 decibels is our breath. 20 decibels is our whisper. 30 decibels is the rustle of leaves. 40 rain. Then we start to get to sort of normal sound. Those are all quiet sounds. Then refrigerator hum is 50 decibels, so that's a faint sound. Conversation is 60 decibels, so that's sort of normal conversation. Then 70 is loud, which is like cars. Then 80 decibels is very loud, trucks. Then we can continue. Hair dryer at 90, helicopter is 100, a trombone is 110, which is a musical instrument. A siren is 120, a jet engine is 130, and the fireworks are 140, and that's where like instant pain happens. So yes, it's how the scale is also important, but also how long you're exposed to it has a really big impact. So if you're exposed to 80 decibels, you want to start like consistently this very loud at trucks, like traffic rate, you're going to start thinking about hearing conservation. So you're going to start, this is why construction workers wear hearing safety. I can't think of headphones. I can't think of what the word is. As we continue, once you get up to 94 decibels, so that is between a hairdryer and a helicopter. If you're exposed to that for an hour, you're going to most likely have some sort of hearing loss. Then it increases faster and faster. So once we get up to that, once you're at 100, so at a helicopter in 15 minutes, if you're exposed to a helicopter for 15 minutes without any hearing protection, then you're going to experience hearing loss. If you are up to 115, so that's getting into between a trombone and a siren, 30 seconds of exposure at that rate without any hearing protection is going to result in hearing loss. Trombones you can play quieter, I'm sure. They're not always that loud. Then 121, so that's a siren. 7 seconds of having a siren is going to result in hearing loss. And then the jet engine and above 140 at fireworks, then that's instant hearing loss. So it's not just about how loud it is, but also how long you're exposed to it. The louder it is, the faster you're going to result in hearing loss. All right, and then we're going to look at soil and water pollutants. We've already learned a lot about soil and water pollutants. We've talked about fertilizers, pesticides, and chemicals spilled into soil can leach into groundwaters, drinking water sources, and waterways, which negatively impacts ecosystems. The 3 common contaminants are heavy metals, workplace chemicals, and pathogens. So heavy metals normally occur in nature and are essential to life, but can become toxic through accumulation in organisms. So you get too much inside of you, then it can be toxic. Arsenic, cadmium, chromium, copper, nickel, lead, and mercury are the most common heavy metals, which can pollute the environment. Mercury, lead, and cadmium are of greatest concern because of their ability to travel long distances in the atmosphere. Sources of heavy metals include mining, industrial production, untreated sewage sludge, and diffuse sources such as metal piping, traffic, and combustion by byproducts from coal burning power stations. An increasingly serious global problem is the management of electronic waste, e-waste, particularly the disposal of used computers and mobile phones, which contain over 1,000 different materials, many which are toxic to humans. So there's lots of ways that we're putting heavy metals into our environments. So the impact of mercury on humans. Mercury exposure can harm the brain, heart, kidneys, lungs, and immune system of people of all ages. In babies and young children, the nervous system can be affected, making the child less able to think and learn. We briefly talked about mercury poisoning in the community of Grassy Narrows as a result of the Dryden power plant or paper mill dumping chemicals into the river, and how they're still dealing with those outcomes. Animals are also impacted. Mercury accumulation in fish may harm the fish and other animals that consume them, including humans. Birds and mammals that eat fish are more exposed to mercury than other animals which live in aquatic ecosystems. Effects on wildlife can include reduced fertility, damaged kidneys, lower growth and development, abnormal behavior, and even death. Whales and dolphins may also be at higher risk of mercury exposure. Then lead, the impact of lead. Lead on humans may cause neurodevelopment effects in children, even at low levels of exposure. So this is why lead paint is not okay. Other effects include cardiovascular, renal, gastrointestinal, hematological, and reproductive effects. In plants and animals, lead bioaccumulates in most organisms and is toxic to plants, animals, and microorganisms. Young fish are more susceptible to lead poisoning than mature fish or eggs. Symptoms of lead toxicity in fish include spinal deformity and blackening on the caudal region, the rear part of the fish. And then how cadmium impacts humans. It's toxic to humans, and exposure can cause pulmonary irritation, kidney disease, bone weakness, and possibly lung, prostate, and kidney cancer. Food and cigarette smoke are the largest potential sources of cadmium exposure for the general population. In plants and animals, cadmium is toxic to plants and animals and microorganisms. Cadmium accumulates mainly in the kidney and liver of the vertebrates and aquatic invertebrates and algae. Acute toxic effects on fish, birds, and other animals may include death and fetal malformations. Cadmium can affect plants, resulting in decreased growth rate and even death. So the major sources of heavy metal released into our environments are through natural, they happen naturally, but also agricultural, industrial, domestic, and miscellaneous. So there's lots of different ways that we are having wastewater, pesticides, industrial waste, organic waste, e-waste, batteries, then landfills, emissions, traffic emissions, incineration, all of these things put heavy metals into gas, liquid, or solid form, and then contaminate water and air as well as the soil. So workplace chemicals are another source of soil and water pollution. This can be liquid, solids, or gases used in manufacturing, mining, construction, agriculture, and business applications. They can be very dangerous to human health, and it can be found in households in terms of herbicides or multi-purpose solvents, cleaners. They often contain heavy metals and other dangerous materials. In order for a chemical to harm a person's health, it must first come in contact or enter the body, and it must have some biological effect on the body. There are 4 major routes by which the chemical may enter the body: inhalation, breathing, skin or eye contact, swallowing, which is ingesting or eating, and injection. Regardless of the way the chemical gets into the body, once it is in the body, it is distributed in the body by the bloodstream. In this way, the chemical may harm organs, which are far away from the original point of entry as well as where they entered the body. So they get spread out throughout your body. Here is a picture of chemical pollutants globally. So there's registered an estimate of 350,000 chemicals around the world, with 3 new potential toxins a day. So 7 million premature deaths are generally result of air pollution. Almost a fifth of these are in soil, of it in China's soil, and over 5 trillion pieces of plastic debris are in the ocean, contributing to the plastic or chemicals, right? So we can just see that there's, out of pollution is an estimate of 10 million deaths a year, whereas smoking, disease, alcohol use, malnutrition, road accidents, drug use, war and murder, all of these are, smoking is at about 7, and everything else is less than 4 million per year. So pollution has a huge impact on death, as well as loss of cognition and fertility, which has greater impacts as well. So it's a big deal. And then pathogens are our last pollutant that we're going to talk about. So pathogens are viruses, bacteria, fungi, and protozoans that cause disease in humans and as well as other animals and plants. So untreated or partially treated human sewage and wild and domestic animal waste are the major pathogen sources. We've talked a little bit about this when we're talking about biosolids. So if all of these pathogens from various waste gets into our water system or our soil system, pathogens that may be found in marine waters include those causing gastroenteritis, Salmonella Ellius, and hepatitis A. People may become infected through direct contact with or ingestion of contaminated water, or by eating raw or partially cooked bivalve shellfish from contaminated or harvested from contaminated waters. Pathogens can enter marine waters via storm water runoff, wildlife and wild waterfowl, illegally discharged sanitary wastewater from boats, and on-site disposal systems for waste treatment. So those are the 3 common types of contaminants, which is the answer to your check your understanding question on number 1 on page 67. All right, so let's consolidate and wrap up, go over the highlights of what we learned today. For lesson 8, the common environmental factors. So with air pollution, we looked at the 5 major contributors to air pollution, which are carbon monoxide, sulfur dioxide, nitrogen oxides, particulate matter, hydrocarbons, and photochemical smog. We looked at light pollution, specifically how ultraviolet light is in our environment and how that has an impact. We looked at noise pollution and how it has eventual hearing loss. Then we looked at soil and water pollution, particularly at heavy metals, workplace chemicals, and pathogens. So we've talked about these pollutions in general, but now a little bit more about what we're actually talking about when we're talking about soil and water pollutants. So hopefully you are able to feel comfortable with these success criteria, that you can explain the causes of air, light, noise, soil, and water pollution. And you can explain the impacts of pollution on humans, plants, and animals. In this lesson, you have a key question is another activity. So you're going to summarize some information. So this is activity 3.1 on page 68. So it's important. Summarizing is a really key strategy for helping you understand and remember what you read. So you're going to summarize the information in section 3.1 by creating questions for the bolded titles and then answering the questions. So you're going to create your own questions. So for number 1, air pollutants and their effects on other environmental factors. So you're going to create, so here's a question example. So what is carbon monoxide? Then you need to answer the question, what is carbon monoxide? Question B, what is sulfur dioxide? You answer what is sulfur dioxide. Then you're going to create a few more questions and then answer those questions. Then you're going to do the same thing for soil and water pollutants and their contaminants. So you're going to ask a question and you're going to answer those questions. This is how helping you remember this information and summarize. You can do this again for other parts of the lessons, but this is just the one that you're going to hand in to help develop that skill. And then you're going to do the review questions on page 69, questions 1 through 15, just like the regular questions that you usually do. All right, so if you have any questions or concerns to reach out to me about this lesson or any of our lessons, you can call me at 807-737-1488, extension 2209, or toll free 1-800-667-3703. You can email me at bronwyn.slate, and that's spelled BRONWYN.SLATE@nnec.on.ca. You can connect with me through Facebook at Slate Wahsa. And also all of our lessons are on YouTube, as well as the videos are linked on YouTube as well at Slate Wahsa. My office hours are 8 a.m. to 2 p.m. So reach out if you want to check in with me. I'd be happy to connect. Though remember, I teach from 9 till 11 in the morning. So that's not a good time to try to reach me as I'm on the air. Thank you so much for joining me today. I hope you have a lovely day, and miigwech.